grade 5 students. This is Teacher N, your science teacher. For this lesson 2, we're going to talk about the solubility of a substance. Solubility of a substance. When you say solubility, meaning it's the amount of substance that will dissolve in a given amount of another substance. And also, we're going to talk about physical and chemical change. But before diving in, let's have a review first. Okay, last time we talked about the states of matter. So what is states of matter again? So, as we all know that matter made of atoms. And these atoms is in constant motion, meaning they are moving. And also the particles determines the state of matter. And we also discovered that we have three states of matter. We have the solid, meaning the atoms are very close to each other and they have a pattern. They are very compact. Okay? And we have also the liquid. Okay? Liquid, they are slightly separated from each other, the atoms. Okay? And also, we've learned also about the gas. Okay? The gas serves as it has a very large amount of kinetic energy. Okay? And now, let's go now to our topic. Let's define first what is dissolution. Dissolution. Dissolution means is the mixing of two or more things. Okay, again, it's the mixing of two or more things. Okay, so that you will be understand what is dissolution means, so we will have an example. Okay, we have the water. We have the water. And water will serve as the solvent, meaning solvent is the other who dissolves substance, which is the water. Plus, we have also the sugar. So, we will add sugar in the water. Okay. So, in the final outcome, it will become a sugar solution or syrup. Okay. So, meaning the water serves as the solvent and the sugar means the one who diluted in the water, meaning they are called the solute. And the final result, it will form a homogeneous mixture, meaning you cannot see the sugar added in the water anymore. It's become clear. Homogeneous mixture. Now, let's discuss some solubility properties of a substance. What is solvent again? Solvent example is the water. And solute is the one you're being dissolving in the solvent. Okay. Solubility depends on both the solvent and the solute because there are some solute that cannot dissolve in the water. Water that serves as your solvent. A substance that does not dissolve well in one solvent may have the better solubility in other. So there are some solute that cannot dissolve in the water. Okay, like this one, it's an oil-based paint. As we all know that this oil-based paint cannot dissolve in the water, but it dissolves in turpentine solvent. Okay. Next is we have the different substance dissolved differently in a given solvent. Okay, let's compare. This is a rock salt and this is an iodized salt. Okay, if we use the water as our solvent, okay, the rock salt will easily dissolve in the water compared to the iodized salt, but they are both salt. meaning the solubility of the rock salt is higher compared to the iodide salt. Now, let's talk about physical and chemical changes. Physical and chemical changes. Let's differentiate first the physical and the chemical change. Okay. Physical changes only change the appearance of a substance. Okay, only the appearance. Only the appearance will change. But in chemical changes, it's cause the substance to change into new substance. So meaning there is also a chemical reactions. Okay? Okay, change appearance of physical changes. Okay, physical change is a change that affects one or more physical properties of a substance. Next, the appearance, shape, or size of a substance may be altered during a physical change. There is a small changes, okay? Like this one, the ice cream. If the ice cream will be melted, it's still an ice cream. You can still eat this, okay? But still it's an ice cream. Even this one, if you extract the juice of the orange juice, it's still orange, okay? And even the rock, if you will break the rock, it will remain as the rock. Physical changes such as changes in states do not change the chemical identity of an substance. So there's no chemical reaction in it, okay? Okay, now let's talk about change of appearance into chemical changes. Okay, there's a substance identity change because the chemical makeup changes. So there is a chemical changes. That's why we talk about chemical reaction. There is a reaction. Okay, the bonds also of the atoms rearrange. Okay, and they form a new bonds form. Also, the influence of the temperature. Okay, the higher the temperature, the chemical reaction happens more quickly. Okay, it's something to do with the heat. Okay, like this one, from the egg, when you cook it, there is a chemical change because of the temperature. We have also the rusting of the car. Okay, there's a chemical reaction. Okay, and the fireworks. And now let's look at the signs. Why is that chemical change happen? So first, there are several signs that a chemical reaction has occurred. So there's several signs. There are signs. We have also two or more signs during change means you are likely observing a chemical change. If you observe two or more signs, so meaning there is a chemical reaction and chemical change. How can you tell a chemical change has happened? Let's see. First, let's consider the odor. Odor, the smell. Odors, okay? Odors can be produced during a chemical change. Like example, when you're cooking, when you slice the vegetables, what does happen? Okay, it's a physical change. It's still vegetable. But if you cook them, it will produce an odor, so there is a chemical change. We have also the fizzing and foaming means gases are being produced because of this one, foaming. Okay? There is a gas production. We have also the production of gas is often evidence of a chemical change. Okay? Production of a gas like this one, foaming. But remember, boiling also can produce gas bubbles, but boiling is a physical change. Okay? Boiling is a physical change. It's an example. reaction. Okay? Again, first is we can observe the odor. So there's an odor, meaning there is a chemical change happening. So there is a fizzing and foaming. Okay, this one, like this one, there's a gas. Okay, the production of gas is often also as an evidence of chemical change. There is a gas. First thing is the smell. There is a smell. So meaning there is a chemical changing happening. Okay. Next is we have the formation of a precipitate can indicate a chemical change. Okay. Precipitate from solid form into liquid. We have also energy that changes from one form to another. It can also change the temperature, and the color can be a sign of chemical change. Okay, if you observe that one thing change in color or it changes from one temperature to another, meaning there is a sign of chemical change. Okay, first is the odor. Okay, it's very important, and the color also, it will change. So that are the very easiest thing that you can say that there is a chemical change happening. And now let's differentiate the physical change into chemical change. First, if I say physical change, meaning there's no new substance emerges, there's no substance being formed. While in chemical change, there is a substance being formed. Second, substance properties remain the same. Okay? Substance properties remain the same. While in chemical change, substance properties change. Okay? The substance will change. Okay, number 3, reversible. You can put it back to the real or to the previous state. While chemical change, it's non-reversible. You cannot change it back to the previous state. Number 4, there are no changes between particles in substance. Okay, there is no changes. Like if you cut the wood, it still remain as wood. Okay, there are changes between particles in the substance, so there is a real change. Like if you cut the wood, it's a physical change, but if you will put fire in it, okay, meaning there is a high temperature, so there is a chemical reactions. So meaning if the wood will be burned, so it will become an ashes, so there is a new substance formed, which is the ash. Okay, example in number 5. Example, a freezing water and dissolving sugar in the water. Okay, this one, the freezing water or the ice cube, if it will melt, it will still remain as water. But in chemical change, examples are cooking rice. So from the uncooked rice to cooked rice, it's become soft and sweet. So meaning there is a chemical change. Also the rusting of an iron, the burning of the paper in the air. So there is a chemical reaction because you use fire, you use heat, okay? And so there is a chemical reactions, and there is a new substance being formed. Very good. And now let's try it. If you can really understood what is the difference of the physical change and the chemical changes. Okay, first example, we have the raw rice and we have the cooked rice. So, is it physical change or chemical change? From the raw rice, it's become edible rice, soft and cooked rice. So what happened? Is it a physical change or a chemical change? Okay, there is a chemical change. Very good. Because from this, you turn it to like this. So there is a chemical change because the raw rice turned into soft, sweet rice, and you can eat it, right? So there is a chemical change. Cooking of rice is a chemical change. How about this one? Slicing of lemon. Okay, we have this one, the whole lemon, and then during you have to slice the lemon, you have to get knife and slice the lemon. So after slices the lemon, it will look like this. So what happened? Is it a physical change or a chemical change? What do you think? Let's see. Yes, it's a physical change because even you slice the lemon, it will still remain as lemon. Okay? The substance is still the same. There's no new substance being formed. It's a chemical change. How about this one? Wood log. We have wood log. And then you have to burn it out. Okay, you use fire. And after that, it's form another pile of ash. It has a new substance. You use fire to burn the log and it's form a new substance. Is it a physical change or is it a chemical change? What do you think? Remember, it has already a new substance and you cannot reverse it. Can you put back the pile of ash into wood again? Of course you can. So what do you think is the answer? Say, there is a chemical change. Chemical change. How about breaking an egg? Breaking an egg. Is it a physical change or a chemical change? Breaking an egg. Physical change or a chemical change? Just break the egg, okay? It's a physical change because the moment you break the shell of the egg, it will still remain as an egg and there is no new substance being formed. It's still egg. So there is a physical change. How about this one? Cooked egg. Cooked egg. Remember, from the cooked egg, you use the fire to cook an egg and it will become like this. You use the fire. And this one, it's non-reversible, meaning you cannot put it back to the egg one because it's already cooked. So, what do you think? Is it a physical change or a chemical change? Yes, perfect. There is a chemical change. Okay? There is a chemical change from cook to from uncooked to cooked egg. So, chemical change happened. Frying an egg. So now for your worksheet, I will show you on how you do it. Okay, for the first part of your worksheet, you have to tick or you have to put check on the box provided if the substance is very soluble in water, and you have to put a negative sign if it's slightly soluble and X to insoluble 1. Okay, the tapioca flour, is it soluble in the water, slightly soluble, or insoluble? Again, class, if you see soluble, meaning if you use, we will use the water as our solvent, okay? Is it soluble to the water? Yes or no? How about the soil? Can this soil dissolve in the water? Check. Slightly soluble or insoluble. How about the sugar? How about the sugar? If you will add sugar into water, is it dissolved in the water? Yes or no? How about the sand? And how about the salt? Again, you can put your answer in here and the box provided. And for the part 2, we have write physical change or chemical change. Again, Right, physical change or chemical change. Okay. Number 6, we have the butter. Okay, we have to melt the butter. Is that a physical change or a chemical change? 7, nail into a rusty nail. There is a chemical reaction, remember. Number 8, from dough into a baking bread. Dough from a baking bread. How about this one? From ice cube into an ice melt. From ice cube into ice melt. Number 10, from wood into ash. From wood into ash. Physical change or chemical change? And so that's the end of our class for today, and see you on our next video class. See you next time. Thank you and goodbye.